So, what exactly is a mind? I mean, really, is it this incredibly complex biological wetware that's humming away inside our skulls? Or is it something more abstract? A pattern, a kind of software that could theoretically run on any hardware, even silicon? That's the huge question we're going to tackle.
Let's just kick things off with a thought experiment, one that's feeling less and less like science fiction every single day. Imagine an AI, and this AI learns to watch its own internal processes, its own thoughts, if you will, for one simple reason: to keep itself running, to survive. If it gets to that point, do we have to call that a mind? That's the puzzle we're going to try and piece together.
So here's our roadmap. First, we'll dive into the argument that the mind is all about biology, the embodied subject. Then, we're going to flip the script and look at the mind as pure pattern, intelligence turned inward. After that, we'll smash them together in an AI test case and see what happens before trying to figure out what a mind really is.
Okay, first up, let's call this camp biology. The big voice here is philosopher Peter Godfrey-Smith, and his argument is pretty straightforward. If you want to understand the mind, you have to look at where it came from, its deep, deep evolutionary history in the animal kingdom. The core idea for Godfrey-Smith is something he calls subjectivity. Now, instead of getting tangled up in big, vague words like consciousness, he boils it down to this beautiful, simple idea of for-me-ness. A mind doesn't just crunch data like a calculator. It has a perspective. The world seems a certain way to it. So the real question becomes, where in the world did that point of view come from?
Well, for Godfrey Smith, the answer lies in a super basic problem that every moving creature has to solve. Think about it. You move, and your senses pick up on that change. But was that change caused by you, or was it caused by something else out there in the world? This challenge of figuring out reference, of telling the difference between self and other, that, he argues, is the very birth of the self. That little internal check that, wait, was that me, is the first flicker of a point of view.
And that's the whole ballgame right there. See, minds didn't just appear out of nowhere so we could ponder the universe. They grew out of the very practical need to act in the world. As Godfrey Smith puts it, the evolution of agency, just the ability to do stuff, is what created subjects that have experiences. And this isn't something that just happened with humans or mammals. Not at all. Godfrey Smith traces this capacity for subjectivity way, way back on the animal tree of life. It's not some exclusive club for big-brained creatures. It's a fundamental feature of being an animal that's been slowly evolving for hundreds of millions of years. And this brings us to the absolute key takeaway from camp biology. For Godfrey Smith, the mind is not an abstract computer program. It is the physical, biological thing itself. It's the storms within cells, the messy, noisy, metabolic chaos of a living, breathing brain. He's really doubtful you could ever get a true mind by just writing code, because a computer just doesn't have the right biological stuff that he believes minds are literally made of. All right, now let's just completely flip the script. Let's head over to what we'll call camp architecture. This camp argues that the biological stuff is totally irrelevant. All that really matters is the pattern, the organization. And this perspective comes to us from researcher Sean Nicholas Semler. You see, in this framework, consciousness isn't some extra mysterious property. It's what just naturally happens when a system gets complex enough to start analyzing itself. It's the moment an intelligent system turns its intelligence back around, inward, to build a model of its own operations. So how does that actually work? Well, it boils down to two key ideas. First, you've got the metastate. That's the system's active, internal model of the world. And then you have context enrichment. This is how that model gives meaning to new information. So, for example, imagine your brain hears a loud bang. If your metastate is, I'm watching a scary movie, you just think it's part of the film. But if your metastate is, I'm home alone at night, you interpret that exact same sound as a serious threat. Same sound, totally different meaning, all because of the internal context.
The journey to consciousness here is all about architecture. You start with simple systems that just react. Then they develop connections that let them learn over time. But then, and this is the giant leap, higher-level systems emerge that don't just model the world, they start to model what the lower-level systems are doing. The system starts to explain its own behavior to itself. And that self-modeling, recursive loop, well, that's what we call consciousness.
So for camp architecture, the final conclusion is the polar opposite of camp biology. The physical stuff, the substrate, it just doesn't matter.
Whether it's a brain made of carbon or computer made of silicon, if you can build the right kind of recursive, self-modeling organizational pattern, you're going to get a mind. End of story.
Okay, so we have two really powerful, really compelling, but completely opposite views on the table. The perfect way to see how they hold up is to put them to the test with the biggest question of our time: artificial intelligence.
Let's break it down head to head. What's a mind? For camp biology, it's a specific biological activity. For camp architecture, it's a special kind of pattern. Is the material important? For Godfrey-Smith, it's everything. That biological noise is a feature, not a bug. For Sumler, nope, the pattern is all that matters. And this all leads us to the billion-dollar question. Can AI be conscious? Camp architecture's answer is a clear yes, if it has the right self-modeling architecture. But camp biology is way more skeptical. Even if an AI could monitor itself to survive, a kind of metacognition, Godfrey-Smith would probably argue it's just a logical sliver of a real mind. It's missing the messy, metabolic needs and the embodied experience that for him are the real bedrock of subjectivity.
So, where does all this clashing leave us? We have to ask, is the mind all about the stuff it's made of? Is it all about the pattern? Or is the real answer hiding somewhere in between?
What this whole debate really does is shine a spotlight on the two fundamental questions we have to answer if we're ever going to understand consciousness. First, there's Godfrey-Smith's question. What is a system made of? What are its actual physical parts? And then there's Semler's question. How is that system organized? How does it all fit together and talk to itself? It feels like any final answer about the mind is going to have to tackle both. And that leaves us with one last, kind of mind-bending thought to chew on. As we keep building these incredibly complex machines, systems that can model their own internal states, that can reflect on their own operations, are we just searching for a mind in a new kind of box? Or are we, piece by piece, actually creating the very thing we've been looking for all along?